Alright, welcome to the final video on factoring. This is going to deal with section 3.8, which kind of deals with a few other categories of factoring. And I'd recommend actually reading that textbook section because it's pretty good stuff. Okay, let's jump right in. Okay, first thing we got to do once again is looking at multiplying polynomials. Let's multiply this out and see what happens. We've got x minus 5 times x plus 5. That's x times x, which is x squared, x times 5, which is 5x. Negative 5 times x, which is negative 5x, and negative 5 times 5, which is negative 25. Hey, look, those middle terms, 5x and negative 5x, will cancel out. And the result is that all I have left is x squared minus 25. This is in fact called a difference of squares. We have a square, x squared, and we have another squared. That's 5 squared. And of course, we have their difference. So let's take a look at these kind of questions. So these kind of questions can be factored using a pretty quick technique. So here's an example. X squared minus 16. Okay, in fact, I know immediately what the answer is. It's the root of the first and the root of the first. And in fact, we'll take the root of the first plus the root of the second times the root of the first term minus the root of the second term. If you were to check this, you would have x squared minus 4x plus 4x minus 16. And notice again, your middle terms cancel out. Wonderful. So in fact, this is the correct answer. I'd like you to try one immediately. Just jump right in and do x squared minus 81. Tell me the factors in 3 seconds. Okay, that's actually all the time you need because, as it turns out, it's the root of the first and the root of the second, and all we do is put a plus sign and a minus sign, and we're done. And that's quite straightforward when you're dealing with difference of squares. Again, it's a square, another square, and their difference. Okay, let's kind of up it a little bit because that's pretty straightforward. We're going to factor 4a squared minus 25b squared. Now this one looks a little bit more complicated, but actually it's just the same thing. It's a square. That's actually 2a all squared. So this is equal to 2a plus something and 2a minus something. And the second term is also a square. That's 5b all squared. So we can put in 5b down here. And in fact, we're done. 2a plus 5b times 2a minus 5b will give us the original expression. Try multiplying it out and you'll see exactly that. For our next problem, let's kick it up even more here, since this is pretty straightforward. We're going to do 81 times x to the power of 4 minus y to the power of 4. And this one's going to kind of give us something interesting. Okay, first off, the square root of the first term is 9x squared. Since 9x squared times itself gives us 81x to the power of 4. And the square of the second term is y squared. Since y squared times itself is y to the power of 4. And we say, oh good, we're done. But wait. Look at this second factor. That's 9x squared minus y squared. Hey, that itself is another difference of squares. So we can keep going. 9x squared plus y squared stays the same. Don't forget this. It stays with us. And now we factor 9x squared minus y squared. And that gives us 3x plus y and 3x minus y. And in fact, we're done. Okay, let me give you a challenge to end it off here. Why don't you try this out for yourselves? 16 minus x to the power of 8. This is a difference of squares. Give it a try. Okay, so I hope you've unpaused and you've had a chance to try that out. Here we go. we've actually got a difference of squares. It's 4 squared on the end, and x to the power 4 squared. And we should notice once again that our second bracket here is a difference of squares. And that becomes 2 plus x to the power 2 times 2 minus x to the power 2. Now some of you are tempted probably to go on with 2 minus x to the power of 2. But as it turns out, that is not a difference of squares. And so in fact, we are done. Just a quick note, in your textbook on pages 190 to 192, you will see 2 other kinds of problems. 2 variable trinomials and perfect square trinomials. The 2 variable trinomial problem looks like this. It's factoring x squared plus 3xy plus 2y squared. But if you look in your textbook, you will see that this is identical to factoring x squared plus 3x plus 2. If you can factor this expression, you can factor the first one. So take a look in your textbook for an example or 2 of that. The last kind of thing that your textbook will talk about is called a perfect square trinomial, like x squared plus 10x plus 25. This one's called perfect square trinomial because, as it turns out, the 2 factors are x plus 5 and x plus 5, which is the same thing. It's x plus 5 squared. So we call that a perfect square trinomial. So once again, take a look in your textbook for this kind of side topic on factoring. Okay, hope it all worked out. Talk to us if you have any questions.